All right, welcome to The Explainer. Today we are diving into something you probably use every single day, the can and the bottle. And trust me, after this, you're going to see the incredible science they're hiding in plain sight.
I mean, seriously, think about it for a second. You grab a can of soda, a jar of pasta sauce, you just assume it's gonna work. You trust it completely. But that trust, it's not an accident. It's built on some seriously mind-blowing and mostly invisible engineering. So how do they actually pull it off?
And this, right here, is the key takeaway. Yeah, sure, aluminum is strong, glass is tough, we get that. But the real genius, the part that keeps your food safe and fresh, isn't the big, obvious wall of the container. Nope. It's in the stuff you barely notice. The coatings, the seams, the seals. That's where the real magic is.
So let's start with that invisible shield. You can't have your acidic soda or salty soup touching raw metal. That would be a disaster for the taste, and it corrode the can. So every single can has this super thin, specialized coating on the inside, a lacquer. That's basically a barrier between the metal and the food.
Now, for a long time, a lot of those coatings used a chemical you've probably heard of, BPA. But as safety standards got tighter, the whole industry shifted to something new. The gold standard is now BPNI. And pay attention to that wording, not intentionally added. That isn't some vague marketing promise. It's a precise technical term. It means they're using newer formulas and have to prove that there's no intentional BPA in there. It's a huge deal. And this stuff is regulated like you wouldn't believe. Don't worry about memorizing these codes. Just look at the table. Whether you're in the US or the EU, there are incredibly strict rules for the coatings, for how factories operate, everything. It just goes to show you that this invisible shield inside your can, it is very, very serious business. Okay, so the chemistry part is locked down. But what about the physics? A can of soda is holding back a crazy amount of pressure. And a glass bottle has to survive being filled with boiling hot liquid for pasteurization. For this stuff, failure is just not an option. It all comes down to pure engineering integrity.
First thing to know, not all cans are created equal. You've basically got two types. The two-piece can, think soda, is pretty cool. It's stamped out of one piece of aluminum, so the bottom and the sides are a single seamless unit. Then you have the three-piece can, which is what you see with soup and veggies. That's a flat sheet of steel that's rolled into a tube, welded shut, and then the top and bottom circles are sealed. And this is where my mind is just blown. To seal that three-piece can, they use something called a double seam. Just look at this process. The edges of the can and the lid are literally folded over each other. A special sealing gunk is injected in there to fill any tiny gaps, and then it's all squeezed together to form a 5-layer, perfectly airtight mechanical lock. It is an absolute marvel of precision engineering, and it happens at lightning speed on the production line.
So, what about glass? Okay, picture this. You pour scalding hot juice into a cool glass bottle. Without the right design, it would just shatter into a million pieces. That's called thermal shock. And it's why every single bottle design has to pass a brutal test, defined by the standard ASTM C149, to prove it can handle those crazy temperature swings. And if it's not the heat, it's the pressure. The force pushing out from inside a champagne bottle or even just a bottle of pop is immense. You can't just cross your fingers and hope it's strong enough. Designers have to prove it scientifically using a standardized pressure test called ISO 7458. These tests are the non-negotiable gatekeepers that keep things from, exploding. All right, so you'd think the designer's job is done once the product is safely inside, right? Wrong. One of the most critical parts of the design process today is thinking about what happens after you're done with it. We're talking about its afterlife. We see that word recyclable plastered on everything. But here's the dirty little secret. Just because something is technically recyclable doesn't mean it will get recycled. Its fate is often decided in a split second by a machine in a sorting facility, and a few bad design choices can send it straight to the landfill. And these right here are some of the worst offenders. That beautiful, full-body plastic sleeve on a glass bottle, it can blind the optical scanners that sort the materials, so the machine just rejects the whole thing. If that sleeve doesn't have a little perforation so you can rip it off easily, it's even worse. Certain inks and glues that don't wash off properly can contaminate a whole batch of otherwise perfectly good recycled material. And now there's a huge financial reason to get this stuff right. It's called Extended Producer Responsibility, or EPR. Basically, it means the company that makes the product has to pay a fee for its packaging's disposal. And what determines that fee? It's all in the design. Look at this chart. Yeah, the material and weight are half the cost, but the other half? That comes from your recyclability score, the inks you use, and the type of label you pick. All of a sudden, smart, sustainable design isn't just a nice idea. It directly impacts the bottom line.
So we've hit on chemistry, we've hit on structural engineering, and we've talked about the afterlife. Let's put it all together. If you were actually designing a can or a bottle right now, what's the pros checklist? What are the absolute must-haves?
Here you go, the 4 commandments of modern package design. Number 1, you have to specify that safe BPA NI coating and get the data to prove it. Number 2, figure out your cap or lid system early and stick to the official standards. 3, demand proof. Get the test results that show it can handle the pressure and the heat. And finally, number 4, design for recycling from day 1. It needs to be part of the actual artwork and label design, not an afterthought.
So the next time you're walking down the grocery store aisle, I want you to stop and take a closer look. That can of beans is not just a simple can anymore, is it? It's this perfectly engineered object balancing chemistry, physics, and sustainability, all to get that product to use safely. It's a little piece of everyday genius hiding right there on the shelf. Thanks for joining us on The Explainer.